Hello everyone and welcome to the second week of these videos for IB Biology. This week we covered membrane transport, but you have to remember that this week was a little bit different because our teacher was not here in the building at all this week, and so everything that we had to do in class was self-taught, self-notes, and we just basically completed assignments that she left for us online. On Tuesday, what this looked like was the Osmosis digital lab, where we found out what was wrong with Clark the cow, which I know was just absolutely thrilling for all of us. But the main information to be drawn from that was osmosis. And then on Thursday, which for me was yesterday, we talked about the methods of transport in general. So there are 4 different methods of transport, and we kind of briefly went over all of them through a PowerPoint assignment, which she called a DBQ, because we were answering document-based questions. While there was no homework for the week, these 2 things do need to be turned in, theoretically, for a grade. And she also sent us an email today, on a day where we do not have school, or do not have her class, we did have school, did not have her class, to tell us that she's going to be giving us a test on Wednesday. Do I know what the content of this test will be? No, I surely do not. She says that we'll hopefully, maybe, possibly, if the world turns around in the right way, go over this information on Monday. So stay tuned for that. And then on Friday, she wants to take us to the library to basically learn how to use Desmos, or to use Noodle Tools again. Yay. But look forward to that next week. But today I'm going to go over the 4 main membrane transport methods, of which there are basically 2 subsections. We have passive transport and active transport. And the main difference between the 2 is that passive transport is never going to require ATP energy. And so, whereas active transport will require ATP energy. And so why this is the case is a good example is when we look at diffusion. So with diffusion, we have along the bottom here an example of what would be called a concentration gradient. On the left side here, we have packed together molecules. They're like squeezed in. It's kind of like if you imagine all of the people in the school standing in one classroom. This is kind of what this side of the concentration gradient may feel like. In the middle here, we have what would be the membrane, or the cell membrane. In this case, I am going to go with cell membrane just because it is a little bit easier, but technically this could be any membrane that your little heart desires. And then along the right here, we've got the open area, kind of like nothing's around. It's like if we took all the people in IB and stood us in a field, this is what that might look like. And so diffusion can basically be if you took everybody from this left side where we're all packed into a room and it's very tight and it's kind of uncomfortable, and then you opened the school doors and just said, go for the fields, like have fun, dude. That's kind of what diffusion would feel like. So it's just the natural way molecules would want to spread out along the gradient and go from where they're tightly packed in to where they're more spread out. So this is going to be any transportation that does not require ATP energy is along the concentration gradient, which is what we call this pretty little picture here. And because we're moving, anything moving from left to right is going to be along the concentration gradient. And then finally, this is going to apply pretty much solely to small molecules and non-charged molecules. So why is this important? Well, when we look at facilitated diffusion is going to be almost the exact same thing, where we're going along this concentration gradient, not using ATP energy. However, this is going to apply to larger molecules and or ionic, which means charged molecules. So I'm not going to give you examples because we all have fingers and we can all Google these things if we desperately want examples. But I will explain a little bit about how they theoretically work. So although they do not require outside ATP energy, they are going to use a little bit of their own stored energy, maybe from these like charges that they have theoretically. And they're going to change what is called the carrier protein, which is basically their little helper to get along the gradient. They're going to use a little bit of this energy, and they're going to change this carrier protein, which is basically going to go from the cell membrane giving them a thumbs down along passing to a thumbs up, and it's going to let them through. So there are very few examples of facilitated diffusion because it's very specific. Like, we have to be along the concentration gradient, not using any outside ATP energy, but still altering this carrier protein with these very specific molecules. Whereas diffusion is going to be a lot more common, and you're going to see that a lot more. However, they're both important, and they are both two examples of passive transport. The next example of passive transport is going to be osmosis. And this was the focus of Tuesday, so we did spend a little bit more time on this one than the others, I think. Osmosis is going to be the same type of situation. It is along the gradient, which the gradient is slightly different, but basically the same here. It will not require any outside ATP energy. However, osmosis always involves water. So what I mean by that, and what I mean by a little bit of a different gradient, is with these solutes. The solutes are going to be something like a salt, maybe, for example, that would be dissolved into water, right? If I have a handful of salt and a handful of water, theoretically, the water and the salt are going to want to bind. And this is what kind of shows us hypertonic, hypotonic, and isotonic solutions. So let's start with isotonic because it is the easiest and it is like the most simple. And that's going to be this little drawing right here. So isotonic is going to be referring to any solution which is the same as like in this example, red blood cell is being dropped into. So if both the water and the cell have the same amount of solutes, there will be no net change in water into or out of the cell. It's going to be the same. Does that make sense? You can't answer. So then when we look at hypertonic, this is going to be when there's a lot more solutes in the water solution that the cell is being put into. In this case, water is going to go out of the cell to bind with these solutes in the outside solution. This is going to leave the cell being very dehydrated, very shriveled. And this is because, again, the water is leaving the cell to go meet the solutes in the outside solution. The opposite is going to be the case with hypotonic. Hypotonic is going to have a lot more solutes inside the cell versus outside the cell. So the water outside the cell in this solution is going to move into the cell to meet the solutes in the cell. And this is going to cause the cell to swell up and kind of become bigger. So again, hypertonic is going to be that the solution has too many solutes. Isotonic is that they're going to be equal. And hypotonic is going to be that the solution has much less solutes. Osmosis is basically just regular diffusion beyond that, other than the fact that the gradient is going to change a little bit depending on the solution. It's still going to always be along that gradient using no ATP energy. Very simple, very great. Like, we love it. Great, awesome. So moving on from passive transport, we have active transport. Active transport is going to be significantly different from passive transport because it is going to require ATP energy. So ATP energy, we talked about it last year, but let's just review. The main thing to remember with ATP energy that I could foresee questions being about is the need for oxygen. So any transportation with active transport is going to be against the gradient. So this is going to be going from where there are very few molecules to where there are a ton. And that's not natural. Nobody wants to go and willingly put themselves in this classroom that is jam-packed with people. That's not what anybody wants to do, and therefore it's going to require some ATP energy to do it. ATP requires oxygen to be made. Otherwise, you only get 2 ATP, whereas if you use oxygen, you have access to oxygen, you are going to make like 30 plus or something crazy like that. I can't exactly remember, but it's a lot more. That's a significant amount more. And so with all this extra ATP that we wouldn't have if we didn't have oxygen, we are going to be able to change the protein shape much easier, much faster, and there's going to be a lot more transportation against the gradient. So what do I mean by the protein changes shape? Well, again, you have fingers, I hope, and you can Google examples of active transportation with cell membranes. But just to give you like a brief rundown, basically the ATP is going to be doing the hard work of changing the shape of these kind of intermembrane proteins, which is going to allow opposite movement, counteractive movement along against the gradient. So the example that I feel like we always hear with IB is the sodium-potassium pump. Again, you can Google. I feel confident in your ability to Google. But the only thing, like, really to remember here, it's going to be against the gradient. It's going to require ATP, which with ATP, the more oxygen we have, the more ATP we're making. So if we have no oxygen, we're making very little ATP. And the protein is going to change shape using this ATP, allowing molecules of all types, more or less, through this protein. So I actually think that's everything I have to say on the topic. Have I missed some things? Probably. Do I feel a little bit lost as well because she wasn't here to, do anything? Yes. But here's hoping to a good quiz test, graded something on Wednesday, and that any of this was either helpful or made sense. Give me feedback if you have any. I'm very willing to make these things better because I am kind of just making this up as I go. And I will see you all on Monday if you're watching this when I put it out, and whenever the next day we have school is if you're not. All right. Thank you all very much. Hope this helped.